Okay, solving radical equations. Let's take an equation. Square root of x plus 2 equals 4. Notice in the notes I rewrite the question down below and then do the method, but here I'm going to do it in red. Brackets around the left-hand side squared. Brackets around the right-hand side squared. From equations in grade 8, we learned we always did the opposite operation. So if you see a square root, the opposite is squaring it, and be careful to make sure that you follow the process. Brackets around the left-hand side squared. Brackets around the right-hand side squared. Now, on the left-hand side, root x plus 2 all squared, like we learned from the last section when we multiplied. Root 3 times root 3 is root 3. Root that squared is root that times root that, and the answer is just, black x plus 2. So, if you have root that squared, the answer is just that. So the right-hand side, 4 squared is 16. Minusing 2 from both sides. Your teachers are going to do less and less of that. 2 minus 2 is 0. X equals 14. Box your answer. Now check your answer. Rewrite the question off to the right. Take the x value you just figured out and substitute it for x. Do it down a couple of lines. On the left-hand side, 14 plus 2 is 16. The square root of 16 is 4. Putting the answer to the left-hand side that I did on the left-hand side, 4. The right-hand side says 4. So check mark, it's correct. And we're also going to have restrictions where we take exactly what was underneath the root. Black x plus 2. And say that that's greater than or equal to 0. Why? Well, because underneath the root needs to be greater than or equal to 0 because we can't square or even root negatives. So we state that. Then we minus 2 from both sides, and x needs to be greater than or equal to -2. Go watch inequalities from Chapter 9 and domain and range in Chapter 10 for more instructions on how to work with inequalities. Remember, if you divide or multiply both sides by -1, change the direction of the sign. So, that's solving radical equations by squaring both sides. Checking your answer to make sure it's correct and finding out what your restrictions are. We now have 2 restrictions. In grade 8, we learned we can't divide by 0. And we learned in grade 8 we can't square root negatives. Those are our only 2 restrictions. Those are the only 2 restrictions we're going to use for this year. We're going to use them all the time. We introduced new restrictions in grade 12. Okay, so the next example, root of x plus 2 outside of the root plus 1 equals 4. Well, we have to isolate the root. So we have to minus 1 from both sides. So we get root that. Plus 1 minus 1 is 0. 4 minus 1 is 3. Then brackets around the left-hand side squared, brackets around the right-hand side squared. We have to isolate the root before we can square both sides. We just learned that root that squared is just that. 3 squared is 9. And again, I told you your teachers are going to show you less steps, and they're going to do stuff like crossing off positives and bringing it over, or just saying bringing it over and saying 9 minus 2 is 7, x equals 7. Now, as you can see in the notes down below, I checked my answer by putting x back into the question and making sure that the left-hand side is equal to the right-hand side. Check mark. And then I did the restriction, and it was the same restriction as the last question. Okay, let's see a quick one. So let's see x plus 3 square rooted equals square root of 2x plus 5. Now, there's a root on both sides, but technically you've already done the first step. Square root both sides. Square both sides. So now we can put brackets around the left-hand side squared, brackets around the right-hand side squared, and the square root of that squared is x plus 3. And the square root of that squared is 2x plus 5. And now you can go back to grade 8 and learn how to solve equations. Solve for x, circle your answer, put it back into the question, and state your restrictions. Okay, I need to shrink this up a bit. And off to the right, let's go for x plus 3, changing it up, minus x minus 1 equals 0. So we have to isolate the root, getting the root by itself. So we have to add x to both sides, and we have to add 1 to both sides. And we'll be left with root x plus 3 equals negative x plus x is gone, negative 1 plus 1 is gone, equals to x plus 1. Now, we have to follow the root, square both sides. So, brackets are on the left-hand side squared. Brackets are on the right-hand side squared, squaring them separately. On the left-hand side, we have root that squared, so it's just that. But on the right-hand side, we have a binomial, and we learned from grade 9 that we have to FOIL that out, x plus 1, x plus 1. So x plus 3 equals x squared. Go back to grade 9 and 10 and learn how to FOIL stuff quickly. Plus 1x is plus 2x. 1 times 1 is 1. Get it equal to 0 by minusing x and minusing 3. I'm not even going to show that step. 0 equals x squared. If I subtract x from both sides of the equation, 2x minus x is positive 1x. And 1 minus 3, subtracting 3 from both sides, 1 minus 3 is negative 2. Look at this. We can factor this thing. So, remember, we did this in grade 10, factoring, and then we learned how to solve by factoring and setting our factors equal to 0. So, what are two numbers that multiply to get negative 2 and add to get 1? Positive 2 and negative 1. Set your factors equal to 0 separately. Solve. Minus 1, 2 from both sides, x equals negative 2. Plus, excuse me, I wrote that one wrong. I'm going to completely rewrite it. X minus 1 equals 0. The factor from above. This one goes here. This one goes here. Add 1 to both sides. X equals 1. Carefully look at the notes. Substitute negative 2 back in for x and realize that it doesn't work and reject it and cross it off. Substitute 1 in. Realize that it works. And again, state your domain and whatever. Okay, let's go below that for a second. Anytime we have a square root or an even root for that matter of any x value being a negative, there's no solution, does not exist. So I don't care what it says underneath it. X plus 99 equals negative. Don't care what the number is. 4. No solution, does not exist. You can't square root a negative. The method above, so set the underneath the root greater than or equal to 0 and solve. But a square root also can't equal a negative. Okay, a quick little algebra. So 2 root x plus 3 equals 6. And again, 2 root x plus 3 equals 6. It's in the notes, in the box. So, I'm going to do the example on the right first. If I want to divide both sides by 2 first, go for it. And then follow the notes and square both sides and check your answer. But what if we just wanted to square both sides? So the example on the left, brackets around it squared, brackets around it squared. We have to square the 2. 2 squared is 4. Root x plus 3 squared is x plus 3. Root that squared is just that. And 6 squared is 36. And then now you could, again, divide both sides by 4 or distribute. Either way, ... X is the same thing as it is. So, square both sides first if you want to. Divide both sides first if you want to. If you can't divide both sides first, probably square both sides, or whichever. Okay, I need to shrink this up a ton. Okay, so we're kind of right middle below the no solution squares. So let's go for root of x plus 1 equals the root of x plus 1. Now, I told you earlier that you had to isolate a root to square both sides. Technically, right now, one of the roots is isolated. So we can square both sides. Whoops. So on the left-hand side, root x plus 1 squared is just x plus 1. But on the right-hand side, squared means we have to square it and multiply by the identical term. So we can FOIL it. Root x times root x is just x. Then we have 1 root x and 1 root x, so it's plus 2 root x. Look at the notes for each of the individual steps. And then 1 times 1 is plus 1. And I remember earlier that we have to isolate a root. Oh, there's another root. So let's isolate it. Let's leave it where it is. Let's subtract x from both sides. The x's are gone. Let's subtract 1 from both sides. The 1's are gone. So we're left with 0. Well, we can divide both sides by 2, crossing off the 2. Then we can square both sides. And 0 squared is 0, and x squared, root x squared is x. So x equals 0. Checking your answer, putting it back into the question, making sure it's the same on the left-hand side and the right-hand side. Then state your restrictions. So we know underneath the root x plus 1 needs to be greater than or equal to 0, but we have another root x, so that also needs to be greater than 0. We can solve the one on the left by subtracting 1 from both sides. Now, if x needs to be greater than -1 and x needs to be greater than 0, we can reject x needs to be greater than -1 and just circle x needs to be greater than or equal to 0. We want to keep the one that is more restrictive. If we need to be greater than both, well, we only need to be greater than 0 because that covers greater than -1. Okay, so in this bottom corner of the notes is just me doing the same process as we just did. Isolate a root, square both sides. Careful with your FOIL, practice those from earlier sections. Check your answer, state your restrictions, only keep the more restrictive one. And then for that matter, there's an example in the bottom right-hand corner. Whoops. There's an example in the bottom right-hand corner, which is just where you have squared squared. So you reverse the process and you square root both sides. Check your answer, obviously. So that's solving radical equations. Square both sides, isolate the root, square both sides. Check your answer, state your restrictions, possibly multiple answers, possibly reject an answer, possibly whichever. Okay, great. So that's solving equations.